Good morning. Today we'll be dealing with the midpoint formula for ordered pairs or two given ordered pairs. So for our objective is to find either the midpoint or the endpoint of any given line segment and attending to precision through critical thinking skills. Let's go first to our midpoint and let's derive the formula for this one. So a midpoint is a point that is what we call equidistant from any two given endpoints of a line segment. In this case, let this be point A and point B there at point A at the bottom and point B on top. Then the midpoint will be equidistant. This is the symbol for equidistant. That midpoint M will be equidistant between points or endpoints A and B. With this being said, then the formula for the midpoint M, according to XA and XB, the X coordinates for the two endpoints, then the midpoint X coordinate will be the average of this both X coordinate values. That will be XA plus XB all over 2. And the same holds true for the Y coordinates. We're going to get the average of the Y coordinates for both A and B. So again, this is our formula for the midpoint of any given two endpoints of a line segment. Let us apply this now to some few problems in here. For the first problem, it says an archaeologist used string to make a grid over an area where she was digging. She discovered a bowl buried at 0.14 and a tool buried at 0.310 on her grid. She suspected that an item was buried at the midpoint of the segment connecting the bowl and the tool. At which position on her grid should the archaeologist dig to look for the buried item in here? So let's try to use our cubes method first in order to analyze this problem here. We just did the C of in which we have encircled the given numbers. Let's consider now U, which is where we underline the given question. It says, at which position in her grid should the archaeologist dig to look for the buried item? Let us box the keywords and phrases. So the 1-4 or ordered pair 1-4 is for the bowl. The ordered pair 3-10 is for the tool. And we're looking for, once again, the suspected buried item. Let's now consider our letter E, where we create our equation in this particular case. So we can say that in here, we can draw this one in our X and Y coordinate as follows, or XY grid as follows. So as we may see, these are both in the first quadrant because all of the X and Y values are positive. Just creating a rough draft about this one. Let this be the 0.14. For the bowl, let's call it letter B. And the 310 will be for the tool. Let's call it letter T. Now let's connect this two endpoints with the segment, line segment in there. And let us now specify the buried item in there. Let's call it letter M for the buried item. With this, let's now use our equation for midpoint. So our equation now will be the following. For the midpoint M, then that will be the x coordinates first. That's 1 and 3. That's 1 plus 3 all over 2, comma. And then for the y values, I'm going to have the following in here. That's 4 and 10. That will be 4 plus 10 all over 2. Let's now compute for this one. And let's do our solution. Trying to solve this thing in here. Then my point M will now be at 1 plus 3 is equal to 4 divided by 2. That will be at 2. 4 plus 10 will be 14 divided by 2 will be at 7. Therefore, we can say that the buried item should be somewhere with the x coordinate of 2 and the y coordinate of 7 in this case. Let's now try to analyze our question number 2 in this case. Let's analyze our cubes approach or cubes method. Let us encircle the given values first. Those are 0, 8, 12, 9, 12, 3, and 0, 2. And then after that, we're going to underline our given question. It says in here, the county planning department designs a new park in the shape of a parallelogram. They put in 2 diagonal walkways. What will be the coordinates of the intersection of the diagonal walkways? So that will be our question. After that, we're going to box the keywords. So this is a shape of a parallelogram, which means that opposite sides are in fact parallel to each other. And that's the symbol for parallel sides. And they put the 2 diagonal walkways. So that's a number 2. And the question will be the intersection of the diagonals on where it will be. So as we may see from our illustration in here, looking at the diagonals from 0, 8 to 12, 3, that only means that this point in here is in fact the midpoint between these two endpoints in here. Similarly, on the next diagonal, from 0, 2 to 12, 9, we can also see that point M in there is in fact the midpoint as well of that particular diagonal. With that being said, then to get the intersection of the diagonals, we simply need to get the midpoint either from 0, 8 to 12, 3 or from 0, 2 to 12, 9 in this case. So let's now have our equation for this particular case. So to get our equation for the midpoint, then the midpoint M should be equivalent to, if I'm going to use these two in here, then I'll simply consider the x coordinates first. In this case, the 0 and the 12, that'll be a 0 plus 12 divided by 2. And for the y coordinates, then I'm going to use a different number. Those are the y coordinates. That'll be 8 plus 3 divided by 2. Again, in here, I simply use the 0, 8 to 12, 3. But in here, I can also use the 0, 2 to 12, 9. And I should be having the same answer in here. Let's now go to solve this particular equation. So in order to solve this, 0 plus 12 will just be 12 divided by 2. That will be at 6. And 8 plus 3 is 11 divided by 2. Then that will be at 5.5. Therefore, the intersection of the diagonals will happen at that point 65.5. Let us now consider the last problem for this case on rhombus. So it says here the diagonals of a rhombus intersect at the point 0 and 410. So we circled already the given numbers in here. Let us now underline the question. It says, where is the other point located? Next thing that we're going to do is to box the keywords and phrases in here. So first, there are the diagonals of a rhombus. There's also the endpoint of the longer diagonal. And we're talking about what the other endpoint of this longer diagonal be. So after this, we're going to our equation. So to provide for our equation, we can draw our rhombus first in this case. Assuming that this will be our rhombus in here in red. So any rhombus will be equilateral. That means all sides are having the same distance or side length. Now it says there's a diagonal in here, and we consider the longer diagonal. Let's use a different color for it. So let this be the longer diagonal in here. And let this be the shorter diagonal in here. With that being said, it says the diagonals of a rhombus intersect at the point 0,4. So therefore, in this case, the 0,4 is on this in here. That will be my point 0,4. And let me call it M, or the midpoint. Now, one of the endpoints of the longer diagonal is at 410. So let us consider this on top as that endpoint of the longer diagonal. That will be at 410. And let's call it point A. Now, the question will be, where is the other endpoint located? So we're talking about this point B in here, which we don't know what XB is and what's YB in this particular case. Now let us consider our equation for this. So our endpoint or our midpoint is already given at 0,4, and that is equal to the average of A and B x coordinates. That will be 4 plus xb all over 2 for the y coordinate, and for the x coordinate, and for the y coordinate, and that will be 10 plus yb all over 2. So once again, our midpoint in here, which is at 0,4, should be equal to the midpoint, which is the average of A and B x and y coordinates each. So which means 4 plus xb all over 2, and for the y coordinate, that will be 10 plus yb all over 2. Let us now proceed with our solving of our equation in this case. So let's solve for this for both the x's and the y. So for the first one, we have 0 and this particular expression in here. So we say 0 is equal to 4 plus x over b all over 2. To solve for xb in here, I would multiply first both sides by 2 to cancel the 2's on the right. 2 times 0 on the left will still be a 0. Then that will be 4 plus xb. And in order to solve for xb in there, I will subtract both sides by 4. With this, 0 minus 4 on the left will be negative 4. On the right, 4 minus 4 will cancel out. Therefore, my xb is equivalent to negative 4. Now, to get the yb, I'll do the same. 4 is equal to this y coordinate in here, which is 10, plus yb all over 2. The same with what I did with the x value. I will multiply first both sides by 2 in order to cancel the 2 on the right. So 2 times 4 on the left will be 8. Again, that will be 8 is equal to 10 plus yb. And in order to solve for yb, I will simply subtract both sides in here by 10. With that being said, 8 minus 10 on the left will be negative 2. 10 minus 10 on the right will cancel out. Hence, I have my yb equals negative 2 in here, which means that the other endpoint will be located at point B, which is at point negative 4 and negative 2 in here. This last problem that we just solved is solving for one of the endpoints should the midpoint and one other endpoint is given. Now take time to solve this particular problem on your own. The coordinate plane below shows Stan's house as a point A and Jerry's house as a point B. What point is halfway between the two houses? Again, let us review our formula for the midpoint. If you are given points A with XAYA and point B with XBYB, then the midpoint will be the average between XA, XB, and the average between YA and YB. Once again, let me know if you have questions regarding this topic. And tell me QUAN-do. You, QUAN-do, math.